Hi everyone, welcome to Electronics with Professor Mughal here again. This is going to be video for especially my fans in Nigeria and Egypt. I have received a lot of requests from some of them, and most of them are high schoolers, and they wanted to learn about how to make a circuit, how to use a breadboard to make any kind of electronic AC or DC circuit. So I've got two very simple examples, and we're going to start off with basically like why we use breadboards, how to use them, and then making a couple of circuits, one series circuit and then the parallel circuit, and then I'm going to move on upon like how to measure and test those circuits, measuring current and voltage. And hopefully from this video you'll earn enough basics that you should be able to do complex things on your own. Okay, so we're going to start off looking at some of the basics of the breadboard. Why breadboard? Why do we need a breadboard? Well, we need a breadboard so that we can make a prototype without having to solder it and create an electronic circuit. Most breadboards will look full size. This is the half size. There's one more size which is a mini size. I don't have it right now, but it's a smaller version of this what you see over here. And then basically I can go in and test my circuit before having to solder it on a PCB. So for example, this right here, I'm applying 5 volts. It's an N circuit. When both inputs are high, it's supposed to give me high, and then any of the one input is high, it basically does not give me anything. So what I've done essentially, I've taken different components. Here I had the LED, I had the couple of transistors, couple of push buttons, few resistors and some wires. I hooked them up, created a circuit, and then tested it. It worked fine, and now I know that it's working. I can take this electronic circuit onto a PCB board and then basically solder it. So that's the whole point of having a breadboard. So if you are an engineering student, you do labs, you will be given something like this. And believe it or not, you know, it's got these grooves right here, so you can have 2 half and then attached. In fact, I can show you here. And this will make a full-size breadboard. So I've essentially taken 2 half breadboards and making them a full size. Okay, so why the name breadboard? Why do we call it a breadboard? Well, believe it or not, the reason we call it breadboard is people used to use screws or nails and to complete the circuit by just, you know, hammering it onto a cutting board, which they would use to cut the bread, and that's where the name breadboard comes from. So that's a little bit of history about it. So what goes into this plastic? Okay, so underneath this plastic we have these metallic strips. This is our breadboard, and what goes underneath this plastic is basically these metal strips. So I want you to focus over here. So these are the power rails, the top rail and the bottom rail. These two are the power rails, and they are color coded. Plus would mean that's a red would mean it's a positive terminal, blue would mean it's a negative terminal, and these are basically connected from here to here. And if you look at it, you got this strip connected all the way from here to here. So if you apply a voltage, the electrons will basically flow from this end to the other end. So they are connected like this. Okay, similarly, if you look at this part of this breadboard, which is this part, you got a lot of rows here, and they are, if you notice, they got 30 rows in here, 30 rows, and each row here is basically a metal strip. So if I supply some voltage over here to this tiny hole, it will propagate through each of these holes because they are just metal strip, like piece of copper metal. And similarly, if I look at the other end of the breadboard, this row 1, these row are basically connected in series because it's just one metal strip. Also notice there's a disconnection between this and this part of the breadboard. So these cells are not connected with these cells. Okay, and the reason for that is because you have the center line, which you can see over here also. So these two banks on the breadboard, they are connected like this, and these two banks right here, what you see, the power rails, those are connected like this. Okay, and usually, as you would see, the breadboard is labeled. So you got A, B, C, D, E, F, G, H, I, J. So that 10 columns right here, these 10 columns. And then row 1, row 2. So in a half breadboard, you have basically 30 rows. And then you got the power rails here on both ends. And then the center line. Okay, all right. Let's move on to the next part. So what I just told you, I'm just going to summarize it. So this right here is the power rails. Okay, and similarly, these are the power rails. Okay, where plus is the positive, and then you got the negative, which is the blue. Okay, all right, awesome. What I think of when I look at breadboard, I basically segregate them into 4 banks. Okay, for me, any breadboard, most breadboards will have 4 banks. So this is bank 1. Okay, I'll say breadboard bank 1. This is bank 2, and I'll label it as breadboard bank 2. And this is my breadboard bank 3, and similarly this is my breadboard bank 4. Now none of these breadboard banks are connected to each other. Okay, they are separate. Breadboard 1 and breadboard 4 are the power rails. Like I said, these should be used in order to provide power to your circuit and to ground. Breadboard bank 2 and 3 should be used. That area needs to be used to create an electronic circuit. Okay, and then like I said, there is no connection between any of these banks. Okay, why the structure or the layout of breadboard bank is like that? Well, the reason it's like that is so that we can use these components and plug them in. If you have seen the IC chip, or if you have seen a push button, okay, we have this center line so that we can make connection, and making a connection like this basically creates an interface or a connection between this bank and this bank. And because these are connected vertically, they need to be hooked up like this. So this way, you're using a center line to segregate this and this. However, at the same time, you are making connection between this part of the circuit and this part of circuit. That's what this center line allows us. Okay, so I hope you get that point right there. Color labeling is extremely important. Make sure all your grounds are going here. All your grounds are going to the blue. All your grounds are going here. Similarly, all your grounds are going here. And all your VCCs and positive VS or power supply, positive terminal, all is connected to the plus, which is this row. Another thing that if I hold my breadboard like this, so this is exactly, they look similar. Again, I got, if I say these are my columns, I got 30 columns, and then I got these 10 rows, 5 here, 5 here, and then 2 rows here, 2 rows here. Each cell has a specification, has a specific ID. So notice here, if I look at this cell right here, this cell is basically at the y-axis you got C, and at the x-axis you got 14. So the specific ID or location of this pin on a breadboard is C14. So every pin or every hole that you're going to use will have a specific pin location or ID. So for example, over here on the y-axis you got H, and then on the x-axis you got 29. So H29. And again, remember, all these cells here are connected. These cells are connected. But this blue cell and this red cell, they are not connected. They are not connected. Similarly, this cell and this cell is not connected because there is a center line between them. However, if I use a wire to connect this pin to this pin, now they are connected. Okay, and that's what this push button was doing. It was acting as a wire to connect this part of the circuit with this part of the circuit. Okay, so we can use these small jumper wires to make these connections. And similarly, if you look at this cell right here, these are all connected horizontally, okay, all the way to the very end. These are all connected. So if I am supplying 5 volts here, each of these pins will have 5 volts, okay? Everything will have 5 volts, correct? However, they are not connected vertically. This red right here is not connected with this blue right here. There is a disconnect, okay? Because these are connected horizontally, not vertically. Similarly, if I have 0 volt going here, ground, all of these will be 0 volt. Zero volt, all the way 0 volt. Okay, so that's the basics of the breadboard. We do understand the anatomy of breadboard, you know, what goes inside beneath this plastic, and then, you know, how to label things and how things work on a breadboard. So let's move on to the next part, which is how to build a circuit on breadboard. And again, like I said, you know, most of the students who asked me this question, they were high schoolers from Nigeria and Egypt. So I kept it very basic, and I might go through detail that you may already be aware of. So just be patient, and then I hope that you enjoy, learn something. Okay. All right. So this is a circuit right here where I have a 5 volt power supply. I have a resistor, some unknown value, doesn't really matter here. And then an LED, looks like it's going to be a green LED. And this is a series circuit. And the reason I call it series circuit, what is the definition for a series circuit? So a series circuit is a circuit where current only takes one path to flow. So current has no other path except for this right here to flow. And that's what we refer to as a series circuit, where each component is connected in series. Okay, so that's the definition of a series circuit. What is a branch? What is a branch? A branch is an element or any component that is that makes a circuit. So here we got a DC power supply, that's one element. We got a resistor, we got an LED, ground may also qualify. So we basically have 1, 2, 3, 4 branches or 4 elements right here. So branches, we have 5 volt power supply, we have a resistor, we have an LED, and if you want to include ground, that would make up the branches. Okay, all right. What is a node? What is a node? A node is basically something that connects the two elements or branches. Okay, so for example, if you look at over here, this is one node. Basically, this node connects a resistor and a 5 volt. Okay, so what is a node? A node is something that connects two components or branch, if you want to say slash branch slash element. All these three terms are used interchangeably. Okay, all right, there's another node right here because it is connecting resistor and LED. So I got this node right here, I got this node right here, I got this another node right here which basically connects LED and ground, and then this node right here connects to the negative terminal of the battery. Okay, all right, if you want to include that. How to build a circuit on a breadboard that resembles this? And there could be a couple of different ways of doing it. I want to show you like how would I approach it myself. Okay, I am basically going to use this 5-volt power supply in order to provide the voltage. And if you look at it, these are already labeled plus minus. So you got plus minus here, plus minus, you got plus minus over here. So if I just hook it up to the breadboard, I am already getting 5 volts of power supply in here. Now, you might not have something like this at home or labs. You might be using some kind of power supply, and they would have basically 2 wires. So what you could do is you can use jumper wires right here, like I'm gonna use. So positive here, and then I got negative here, and then positive goes to positive and negative goes to negative. Okay, and I can also double check that I am getting 5-volt DC by connecting the alligator clips to the power supply. Okay, actually these needs to be interchanged. This is going to be ground, so this is going to be here, and this is going to be positive. And then if I just hook it up, notice here I am getting 4.99 volts, and I am supplying 5 volts right here. So looks like we are good. We are getting the right amount of voltage. And now I can unplug all of this. I just wanted to show you that if you don't have something like I have, you can always use cables to provide power to these power rails. Okay, now I'm going to switch back to this thing right here. Okay, all right, now I am making this circuit right here. Okay, I've already taken care of 5-volt DC. I need to work on resistor. Now I'm not gonna bother too much about what is the value of this resistor, but I'm just gonna pick a random piece, resistor of some random values. Notice here you have a resistor. This terminal is connected to 5 volts, and this terminal is connected to this terminal of the LED. Okay, so I'm gonna work on this node first, and because I know the positive is the red, I can just put positive here and then insert it to this hole right here. Okay, so it's pretty simple. I have positive 5 volts coming in, positive 5 volts goes through resistor, and so we are here now. This is this node right here is this node. Here I need to connect an LED. Okay, so let's get an LED. You'll notice here LED will have basically 2 legs, again 2 terminals. One leg will be bigger, one leg will be smaller. Bigger leg is positive. Okay, so bigger leg is going to be positive, and the smaller leg is going to be the negative. Okay, all right. So notice here, this column is connected vertically, right? So I need to make sure I'm choosing the same column, and I'm going to the other side of the breadboard, which is perfectly fine. And like I said, you know, there could be, if you tell me to make the circuit again, I'll do it differently. So I want to use maximum space I have on my breadboard. I want to make sure that my circuit looks neat and tidy, okay, and also compact at the same time. Now that I have my LED, the positive terminal is connected to this node. The positive terminal is connected to this node. Negative terminal needs to be connected to the ground. And I know I have already ground this blue thing, correct? So all I need to do is use a jumper wire. Use a jumper wire. And make sure I am using the same column because they are connected vertically, right? And then connect this to ground. Okay, connect this to ground. Now as soon as I basically pull the wire to the ground, the light lit up and the green light is up. And the reason for that is because now we have the electrons. Remember, there are two ways you can think of electrons flowing in a circuit. The conventional is they always flow from a higher potential to a negative potential. So they will be moving clockwise direction. And now that I have ground here connected, I basically have completed a route for electrons to flow from here to here, basically flowing like this, and they keep on doing it. And therefore, you see the green LED light is up. Okay, it's fairly simple and a very good way of making a circuit. If I have to remake this circuit, so when I was a newbie, when I was first learning electronic circuits, I would basically draw a circuit just like I have and take it and would basically exactly replicate it. And the reason I would do that is because early on it was easier for me to follow something like this on a breadboard than having to do it just whichever way I want to do it, if that makes sense. Okay, so how would I do that? Well, I got this resistor on this visual circuit diagram like this. So I will basically just put it like this. Okay, I'll just put exactly how I have it on a piece of paper. Okay, and now I'll see, okay, my resistor, the other terminal is connected to the diode. Again, taking the longer piece and connect it exactly how it appears on the circuit. Okay, all right, so I got my resistor, and I got my LED. Now I got the two basic components I had in there. Now I need to take care of the voltage, right? The positive and the ground. And for that, I'll use a jumper wire. Okay, I'll use a jumper wire for the ground. I knew I need to do that like this. And for the VCC, I'll take this node, the other terminal of the resistor, and connect it to the positive VCC. And this goes over here. And basically I have my circuit complete. So this circuit looks comparatively very similar to what I have over here. And the previous circuit was also working, but it was a little different. So I hope you got the basics covered here. And like I said, you know, you can make these circuits different ways. Okay, now the second part is how to, now that we know how to build a circuit on a breadboard, how would you measure a voltage? Measuring the voltage is is fairly easy. All you need to do, so say you are basically trying to measure the voltage across this resistor. Okay, so all you need to do is connect your multimeter across these two resistors. Okay, that's all you need to do. Okay, this is your multimeter. Okay, take the positive, well, because resistor does not have any polarity, so it really doesn't matter where you connect the positive or the negative terminal. It might give you negative polarity in some cases, but I would have my positive terminal here and negative terminal here so that I don't get confused by the polarity. So I'm gonna put my resistor here and then measure the voltage. So it looks like I am getting 2.3 volts. Okay, 2.352 volts. Okay, so voltage VR across the resistor is 2.353. Okay, all right. Let's now measure the voltage across the LED. Across the LED. What I'm trying to do here now is measure the voltage across the LED. Across the LED. And what I would do here is basically connect my multimeter Okay, so I'll have positive terminal connected to the red, positive terminal connected to the red, the positive terminal of the LED, and then the negative terminal connected to the black terminal of the and now look at the voltage. The voltage now, the voltage across the green LED is 2.630. 2.630. Okay, all right. I am going to move this aside and I'm going to unplug these two cables. Now, if I add these up and I get 3 here, 5 plus 3 makes 8, 3 plus 6 means 9, and then 2 plus 2 makes 4. 4.983 volts. The total voltage applied to this circuit is 5 volts. Out of that 5 volt, 2.353 volt is the voltage drop across the resistor. That means 5 minus 2.353, the voltage at this node would be 2.630, 2.630, which is a voltage drop across green LED. And if you look at the data spec for a green LED, the voltage drop, the forward voltage drop across a green LED is somewhere in the range between 1.9 and 3.5. So this number 2.630 volt for this circuit is the voltage drop across, and if I add that up, it basically comes down to 4.983, very close to 5 volts. Another thing we are learning here, we know how to measure voltage here. We have built a circuit. What is a KVL? What is a KVL? KVL stands for Kirchhoff's voltage law. Okay, and the best way is to understand KVL is basically when you go up high on a steepy mountain, you basically gain some kind of potential energy, right? When you get to the very top. So when you go down, you release all that energy. So some energy went in when you were going up, and some energy was released when you went down. And these two energy are, according to the conservation law of energy, they are equal. Similarly, voltage in a system, is equivalent to the voltage drop across each component in a circuit. So the voltage law states that for a closed loop series, this is a closed loop right here, the algebraic sum of the voltages around any closed loop circuit is always equals to 0. Okay, so let's get the equation right here, and we're gonna go in a clockwise direction since our current is flowing in a clockwise direction. We're gonna start off from here, so from here, basically here, and go this way. So here the potential is going from negative to higher. Negative to higher would mean basically going up, so you're adding that energy. So in this case it will be 5 volt. Okay, now let's move over here. The polarity over here is going to be plus minus. Plus minus would mean going down. That means a drop in the energy, so you'll have a negative sign, minus 2.353 volts, minus 2.630. Remember, again, 5 volt, you went up, so you gained energy, so you have a positive sign. When you came down, you were releasing energy as you were going down, so you have a negative sign right here. So minus to positive, going towards in a clockwise direction would be positive, and then positive to negative, from a higher potential to a negative potential, lower potential, you basically have a negative sign. And like I said, in a closed loop, the algebraic sum of all the voltages always equals to 0 according to the KVL law. So if I add these, I'll basically get very, very close to 0. 4.983. To be precise, I'll get 0.017, which is approximately equal to 17 millivolt. Remember, these multimeters have some kind of tolerance also, so these numbers are like not 100% accurate, but we have been able to justify that the voltage drop across these components makes sense because what we are getting is almost close to 0. So that's what the KVL stands for, Kirchhoff's voltage law, and in any electronic circuit this always needs to be justified. If it's not, then maybe you did something wrong in your calculations, okay, or something wrong with your measurement tool.